Conductor, splicing, and termination. Termination and splicing. Conductor terminals and splicing devices must be identified for the conductive material, copper and aluminum, and they must be properly installed and used. Well, using language must be properly installed and used. Isn't that a 110.3b? Mm-hmm. You have to install it according to listing and labeling instructions. So sometimes the code gets a little redundant, which is not a problem there. These are all different types of wire connectors. Okay, well, this is for copper only. Be careful. There are applications where the equipment is marked copper conductors only. I've seen that in on PV installations, some PV equipment, and I forgot some other equipment. I don't know of anything marked aluminum only. Okay, but if it's not marked at all, it's copper. If it's marked aluminum, it's only aluminum. If it's marked copper or aluminum, it's copper or aluminum. If it's marked aluminum copper, it's aluminum and copper. If it has a 90 on there, that means it's for 90 degree C terminal rating. If it has a 75, then it means it's a 75 degree C rating.
Just a 7.
7
or 7.
9.
7 is a 75 degree C rating. Thank you. Here's an example. This is copper, 90 degree C, and aluminum. Here's a wire range, 6 gauge to 350 kc mil. And I'm not quite sure why it has a 250 amp. I've never seen.
That's in a meter sockets where that's at. And they do actually, for whatever reason, have the amperage rating on the lugs, and I'm not sure why that is.
Yeah, I'm not sure why they would put that in
Almost all the meter sockets have this stamped on there.
The use of aluminum wire and penetrox or no locks, that's not required. That used to be done in the 70s. Actually, not the 70s. 70s when we put it in and we caused fires. And then it was the 80s that we came and we realized, oh, we caused fires in the 70s by using aluminum wire.
Put some grease
apparently, is the oxygen reacts to the aluminum, and so you have aluminum oxide, and makes it's a nice little bond of a compound of an insulator, and then of course you put in the terminals, and this wire was not designed for this lug because this was designed for copper, but this wire was aluminum, and they have expansion coefficient different between the two. It gets hot, and then this thing just gets charred, and all of a sudden it turns into like a steel, right? It's a steel. And we found out, oh, we were supposed to take a brush and brush the aluminum off. We're supposed to put a penetrox on there. And by the way, you don't want to put that on batteries.
Yeah, bad idea.
Because I thought this is so good for aluminum, and I was changing a battery thing. I'm putting this baby on my battery. I put it on my battery, and I think it was like 2 days later, it's like I was a dead battery. Yep. Because I don't remember what happened. It becomes an insulator, I guess, when it gets on the lead of a battery. I don't know what. Don't put it on a battery of a car. I'm just telling you that. So today, aluminum wire is designed not to having any penetrox. Brian.
While we're talking about lugs, if you go back to the lug that had the marks on it, the printing on it, there are occasions when you're also going to see that a lug that's listed or rated for multiple conductors, it'll actually tell you on the lug that it is. And I just want to point that out. We have all these things we're talking about. You can't put 2 wires under a lug, this and that. That's one other marking that you'll see on a lug, and we probably need to get one of those, a picture of one of those.
I thought we had one with a split bulb bug. I don't know what we did with that.
I don't know.
I thought we saw one.
We should have that.
But we'll get that when we get into the number of wires under a lug.
Okay, perfect.
We're going to get that in a second. Okay, now, if a manufacturer of the wiring, aluminum wiring, says that you shall use some kind of an inhibitor at the end on termination, then you would be required to do that. So it's not a requirement unless the manufacturer requires it. And to my knowledge, manufacturer doesn't require it. Finely stranded flexible conductor terminations. Connectors and termination for conductors more finely stranded than Class B and C, which is contained in Chapter 9, Table 10, stranding must be identified for the conductor class. Now watch this. This right here has to be identified for the conductor class. You see where it says 4-aught? That means it would be for a Class B and Class 3 conductor is 4-aught. When it shows you 3-aught and it says the word flex, that means for finely stranded conductor. So this could be used for finely stranded conductor. If it was not marked flex, then this connector could not be used for finely stranded conductors. Also, it says it must be identified for the conductor class. You could get a conductor finely stranded, and you might want to put it under a connector. If you have a twist-on connector is not suitable for finely stranded conductors. So you go to a manufacturer like Burndy or Ilsco, somebody, and you look at a catalog, and you see they sell these little barreled lugs, barreled sleeves, I guess, better. Okay, and all you do is you slide it right on there, and then you put it on the conductor on the outside of the stranding, you put it under the set screw, then you turn it. If you take a look at the catalog, you'll notice in their catalog, throughout the catalog, you'll see a UL symbol all over the place. When you get to this sleeve that goes on there for the finely stranded conductors, it has no UL marking on there, no identification on there. You know why? Take a look at the rule here. Because the manufacturer identified it. Remember the definition of identified in the beginning? For a specific purpose. And because it's in the catalog, identified for finely stranded conductors as a sleeve, then that is what you use. It did not say approved. It did not say listed. Did not say labeled. It said identified. Because they don't make a sleeve that's listed at all. It's not even taken to the testing laboratories. Brian.
Well, I was actually trying to look up the exact terminology for it real quick, but there's also another method that's very common, and in fact, Camlock connectors all come with a little square of, I think it's like brass or copper foil, and you actually just wrap that around, and then it's got a little wire, and it's got instructions that you twist it to hold it in place, and it's thick enough it does the same thing. But it doesn't have to be listed, it just has to be identified, and it's identified just for that purpose, to keep the conductor from expanding.
Okay. Conductor terminations must ensure a good connection without damaging the conductor, and must be made by pressure connectors or splices to flexible leads. I think this is a cool this connector right here, this compression fitting here. That's when you have this like 500 kc mills and you got to put it in a lug that says 4/0. Right? You don't cut the strands off.
You start getting into that, Mike, when you get into voltage drop. You start upsizing your wire starts getting oversized from your breaker. Now you've got to reduce it down to terminate into your breaker.
Perfect example. This sleeve right here, I'm not quite sure. Well, that's
just
a
a
butt
splice, yeah.
Yeah. Terminals are listed for only one conductor unless marked otherwise, as you were talking about.
Oh, yeah, that's what I was talking about, yep.
So this is not marked for two conductors. And clearly, this was never marked for two conductors. I'm not going to tell you this was my job and I did this, but in the 70s, I'd have been pretty proud, to be honest with you, if I'd done that.
Yep.
Because that's how we did it in the 70s.
Yeah.
We twisted the copper, the aluminum, brought it out of the way, put it on their lug, got a sheet metal screw, got the fender washer, put that baby in there. You got to realize in the 70s, we did not understand what equipment grounding conductors were. We were just getting these things out of the way. There was a mechanical nuisance.
Yeah.
Then, of course, we've gotten a lot more educated, realized, of course, equipment grounding conductors terminate in terminals, right, in equipment designed for that application. Conductors, one wire per terminal. Unless marked otherwise, terminals are listed for one wire. Split bolt connectors are listed for two conductors unless marked otherwise. So clearly, this case here, we're fine because they're marked for two conductors. Square D breakers, up to 30 amps, right? Yep. Square D breaker up to 30 amps.
QO.
Right? QOs, right?
Yeah.
You know, QOCs, I guess, QO, whatever. And then you just put on both sides of that screw, which is fine. And they'll tell you the size wire that you can use, of course. Well, because it's identified for that application. Yes, Brian.
And some of the larger terminals, you can actually tell they're either oval shaped or they've got a little oblong cutout in them, and that's your immediate indicator that, yeah, this is probably takes more than one, and then you can look and you can see immediately what it'll take.
I got a comment on one of the streamers on the aluminum for the meter, is that somebody might be running larger conductors because it went up to 600 thousandths.
Oh, I see.
The fact that the wire went up to 600,000, listen, whoa. We're just telling you the lug is between 6 gauge and, let's go back to that one back here.
Okay.
Victor Amons said that.
That makes perfect sense.
Okay. The fact that it can go up to 350 kc mills.
Right.
I don't know what, we can take a look at 310-15B16, 350 kc mills at 75 degrees C is probably rated more than 250 amperes.
Sure.
310.
So it's rated 310. However, you know, bigger wires in there. And maybe even compact conductors might have been installed.
Right.
So you put a larger compact conductor inside there, but no matter what, this is utilities they're kind of trying to control the current going through their meter socket enclosure.
Through the meter itself.
Exactly.
Yes.
I mean the meter itself.
Yep.
That as well as meter socket enclosure.
Sure.
Is it 310 on 310-15?
350 copper is 310 at 75.
Okay, 310, but hey,
What is
250
aluminum?
amps when you do your calculation. I mean,
Aluminum
when
is
you do the
250.
Aluminum, it's 250.
250 at 75.
aluminum is
250 at 75.
at 75. Okay, so if you're going to go copper, we still don't want to go more than
Right.
250 amperes. So that's information.
Learn something every day.
110.14b, connectors must be spliced by an identified splicing device. I guess we could put that crimp on that you were talking about.
Yeah.
You're saying that guys use...
The Buchanan crimper. So, and I actually looked up the prices on green wire nuts. They've called the supply house. They've come down a lot. But when green wire nuts first came out, it was a very common practice for a lot of the guys to use Buchanan, little Buchanan sleeves instead of green wire nuts, because you had the benefit of being able to pass one of the conductors through it, which you couldn't do with a regular wire nut. They're a little bit of a pain because to take them off, you got to get in there with your dikes and cut them off. But the green wire nut, they were stupid, maybe 15 cents, and a little Buchanan's like 2 cents.
Yeah.
And so that was kind of, so when the guy asked you the question about the Buchanans, that's why that was very common with residential guys.
I remember the day this came out. I went to the trade show and like, what is that? That was the coolest thing in the world.
They are super cool.
So now, we're not going to detail. Here, 110.3b said follow the instructions. And when you have twist-on wire connectors, it says this: hold strip wires together with ends even, lead stranded wires slightly, pre-twisting unnecessary. So there's a lot of guys that want to twist the wires together before they put it on there. Listen, I've been to Ideal's testing laboratories and where they have all the wire connectors and you have all the thermal couplings and the cycling back and forth, this and that. I said, guys, you got to tell me, do you have to twist them on? They go, no, Mike, we don't twist them on. We just put it on there, and that's how we test everything. We don't twist things together, because when you twist it together, you might actually be changing, because I'm not sure if it's even, well, I guess they're not going to say you can't twist them, but they were never tested with being twisted. Brian.
Well, and here is something that probably we all are guilty of, and that is not maybe when we first started knowing how to make a proper splice. And you can actually look, and there's actually a torque for those, and a lot of them in the bag of wire nuts, it comes with a little fitting that you can actually use a torque screwdriver. And so if you don't tighten them down enough, it doesn't actually make a good connection, which is why everybody's like, oh yeah, you got to twist it first. Well, when you pull the wires apart and nothing happens, that's because you didn't put the connector on tight enough to begin with.
Well, now that, but probably put too many wires on the connector.
Or too many wires, for sure.
Everybody with that connector puts it in their drill.
Yep, and that's true, very true.
Drives it right through the end of the wire nut.
That's also a big problem.
Say that again. What is the problem?
There's a little, it's like a little bit that can go, it's supposed to go in your torquing tool, but it doesn't. They put it in their cordless drill because, how much faster is it to just,
I'm thinking, and if you go too far?
It comes right out the end, especially solid wire will come right out the end of the wire nut.
Oh, that's a problem.
Yeah.
All right. Splicing joints and free ends of all conductors must be covered with insulation that's equal to that of the conductor. So, if you're not going to use something, you got to make sure you cap it off. Underground splicing. Single UF or USC conductors can be spliced underground with a device that's listed for direct burial. And wire connectors are listed for the ones that are listed for direct burial in a wet location are fine.
Yep.
Don't have to have some kind of special kit. You just put a wire connector but it's only where single conductors are permitted to be installed underground, which is pretty much always. As long as you just got to get 300.5 burial depth. So you can put single conductor. But it has to be single conductor that's UF cable or single conductor USC cable. So these are cables conductors. Okay, now let's you ready? Look at me here. 110.14 C1A1. Number one, I hate it that you're C1A1. So Brian, let's see if we can make a proposal to just simply make it a simpler list.
Okay.
In other words, it's going to be 100 amperes or less, over 100 amperes, and that it's not all into all these different parts. So number one is all these little things nested into each other. Matter of fact, you know what I'm going to do? I'm going to get the code book, and I'm going to find that. If you have a code book, do the same thing on your end. 110.14 C1, and I'm going to read it. The determination, okay, let's go a little higher than that. Temperature limitations. Okay. Remember we didn't talk about that. Okay, I deleted it already. Heinz,
Sir?
years ago when I first got in the trade, we ran branch circuit wiring. We used TW wire. And then we used for branch circuit. And we used THW for feeders. TW is rated 60 degrees C because there's no H in it. THW is rated 75 degrees C. And when the UL tested, or the testing laboratories tested equipment and breakers, they sized the wire based upon the rating of the wires that they had at the time. And since branch circuit wires were rated for 60 degrees C, when they had a 50 amp receptacle or 30 amp circuit, whatever it was, they ran TW wire. So they sized the wire based upon the 60 degrees C column of table 31015B16. So a 50 amp circuit, if you went to table 31015B16, a 50 amp circuit would have been a 6 gauge wire. 50 amp receptacle, 50 amp breaker, they put a 6 gauge wire right on that specific terminal. Now the 6 gauge wire had mass, right? It has a certain amount of mass. So when they calibrated the breaker, the 6 gauge wire and the 50 amp breaker, or the 6 gauge wire and the 50 amp receptacle, the heating, the thermocoupling, and the way the whole thing worked out was that it would be fine. Then in the 70s, late 70s comes out, they came up with this installation called THHN. We didn't know what the heck this was, but we heard that THHN had a higher ampacity. So now 6 gauge wire is rated a lot more, is rated 70 amps. And then we found out that 8 gauge wire at 90 degrees C, THHN double H 90 degrees, was rated for 50 amps. Like, all right. Instead of me running 6 gauge wire for ranges and ranges, and running 1 inch EMT, we could now run 1 inch EMT with 8 gauge THHN, and we're like, wow, you can push it in there. We're like, well, why are we running 1 inch pipe anymore? So then we start running in 3/4 inch pipe with 8 gauge wire, and we were doing fine. We were happy. And then we hear some some issues that, these guys are running 8 gauge wire, putting it on a 50 amp breaker, putting it on a 50 amp receptacle, when the receptacle and the breaker was sized at the calibration of the testing with 6 gauge wire with the mass. They were never sized with 8 gauge wire, and so now we're violating the listing of the product by sizing the conductor using the 90 degrees C wire. Means they can be a lot hotter than the 60 degrees C terminal ratings. And then all of a sudden we realize, wait a minute, no. We don't care what the insulation or the rating of the wire is. We care that you have a certain amount of mass. So that when you size wire to circuits, you have to size the wire to the terminal rating of the equipment. Now, we talked about 11014, about the copper and aluminum and the 7 and the 9. You can get lugs that are rated for 90 degrees C. But if you put that in a piece of equipment, you cannot size the wire to 90 degrees C because the equipment is to be sized to 75 degrees C. So now we know, anytime you terminate a wire to a piece of equipment, you have to comply with a certain default condition. So let's take a look at this default condition. The determination of termination provisions of equipment shall be based in 11014 C1A or C1B. What's C1A? C1A has to do with termination of equipment for circuits rated 100 amps or less, or marked for 14 to 1 gauge wire, shall only be used for one of the following. Basically, number one, if it's 100 amps or less, you would size it based upon the 60 degree C terminal. So a 50 amp circuit would require a 6 gauge wire. But number 2 says, conductors with higher temperature ratings, provided the ampacity of such conductors is determined based on the 60 degree C ampacity of the conductor size. So you can use 90 degree C wire if you want to, right? So you can put 60 degree C rated wire. Or you can put 90 degree C rated wire, as long as you size the wire to what? To the 60 degree C terminals, which is 6 gauge wire. That's 1 and 2. Okay, now, conductors with higher temperature ratings are permitted if the equipment is listed and identified for use with such conductors. So now, if I get a breaker that's rated 50 amps, but it's rated 60/75, or it's rated 75, then I can size the wire based upon the 75 degree C. You with me?
Yes.
You guys with me there?
So far.
So let's just stop that one spot first. So let's go over here. So now, a 50 amp device, 100 amps or less, is assumed to have 60 degree C terminals, which means you have to use 60 degree C sizing conductors. Unless listed and marked otherwise, conductors must be sized using a 60 degree C column. So in this case here, since this is a 60 degree C piece of equipment, I cannot use 8 gauge wire because I have to size it based upon the 60 degree C column, and 8 gauge wire is only rated 40 amps. Okay, guys, we all there?
Yes.
Now, let's go on to C1A3. C1A3. Conductors with higher temperature ratings, if the equipment is listed and identified for such use. Oh, wait a minute now. If you take a look at a range receptacle, and you actually look at the metal cover range of the metal mounting yoke of that, it will be marked 75 degrees C. And if you look at a circuit breaker, today's circuit breakers, it will be marked 75 degrees C. So now, since both equipment is rated 75 degrees C, 110.14C13 will tell me then I could size the wire here based upon 75 degrees C. And if I go to the 75 degree C column, I could use 8 gauge wire, which is rated for 50 amps. Brian.
So now let me understand if what you just said. You said today's breakers, the terminals are now rated for 75
I'm
degrees?
sure they all are.
Really? Okay.
Oh, oh man, many years
Okay.
ago. Now here's what happened. The breakers were never rated for 60 degrees C. The wire is rated for 90 degrees C, and nobody paid attention to the terminals.
Sure.
Then all of a sudden we get this problem side here. Then all of a sudden, guess what happened? We started bringing the wire size up to get the right terminals.
Sure.
And then the device manufacturers, they changed their marking. So then we started running smaller wires. And then we come to find out, yeah, but the breakers didn't change their wires. Okay? So then the breaker guys, look at Tom. Tell me
Right.
at Tom Dimitrovic at Eaton that he doesn't find out about this. Tell me he's not going to products.
Of
And
course
tell him,
he
listen,
is.
guys. So now they go and get their products. Now they have probably changed the standard or whatever they had to do. They get it
Sure.
tested. More than likely, they didn't change anything.
I'm sure.
They just went ahead and said, hey, can you get this thing tested for 75 degrees C? And that copper wire, the 6 gauge wire, it wasn't that much of a heat sink, any different than the 8 gauge wire, and it worked out fine. So now the breakers are rated for 75 degrees C, and it'll be marked. Equipment will have to be marked 75 degrees C. Now, 100 amps or less, they have to be marked to indicate
Right.
75. If not, then they're rated 60.
Okay.
So that's how we handle this.
That's good to know.
Okay? So now, 75, okay, when I run 75 degrees C wire,
They're still rated as
I'm good with 8 gauge wire. Now, let's go over a little further now. B. B said, provisions of equipment for circuits rated over 100 amperes or marked for conductors larger than 1 shall only be used as follows. Number 1, use 75 degree C wire. Well, we don't have 75 degree C wire anymore. Not for all practical purposes. All right, well then use higher rated temperature wire. Okay, 90 degrees C. Provided the ampacity of the conductor does not exceed 75 degrees C. Well then, if it's over 100 amperes, I will size the wire based upon the terminal rating of 75 degrees C. Even though we might have 90 degrees C wire, I can't use the 90 degrees C ampacities for sizing purposes. So here's your 75 degrees C column that we would use for 100 amps or less if it's marked. Or we'd have to use the 6 degree C column for 100 amps or less. Now what we have done in our textbook, Brian, that we want to make sure we're consistent, and Mike, same thing in our graphics. Anything that's 100 amps or less, I changed from saying it's rated 75. I simply did not say anything at all. So if I say size the wire to this 50 amp circuit, well then you'd have to go to the 60 degree C column to size the conductor. And the reason I did that also is because when you run non-metallic sheath cable, NM cable requires you to size the conductors to the 60 degree C column of table 31015B16. So by me not saying anything about terminals, I always know that the wire size 100 amps or less will be correct at 60 degrees C. But every once in a while in my questions in my book, I specify, assuming the terminals that are rated for 75 degrees C, well then we go to 75 degrees C column for 100 amps or less. So I'd have to tell us that there's marked for 75 degrees C for 100 amps or less. Now, let's go to C2. This is a biggie. Separate connector provisions. In other words, they're not part of the equipment. Separately installed pressure connectors shall be used with conductors at the ampacities not exceeding the ampacity at the listed and identified temperature rating of the conductor.
Connector.
Of the what?
Connector.
Of the connector, sorry. So now, let's take a look at this picture right here. So now, if I have this connector right here, and it will be rated for 90 degrees C, that means that the conductors that I can terminate on this could be sized to 90 degrees C. But when I terminate the equipment here, okay, this has to be sized at 75 degrees C because it's terminating on equipment. This is terminating on pressure connectors, not equipment. This can be sized at 90 degrees C. Now, what's the theory here? I could run 75 degrees C size conductors to here because the breaker is rated for 75 degrees C. I could then put a power distribution block and make a transition and run 90 degrees C size conductors at this location here, then make my transition and then go back and size for 75. What could happen is this. If this is a 400 amp breaker, you would put 500 kc mil wires here, and then you'd run 400 kc mil wires in between, and then you would run 500 kc mil wires at the termination. Eric.
Yeah, so I wrote an exam question once, and I said, assume the terminations are 75 degrees. Well, the student did the work for 60 degrees, and then told me, he said, well, I can't assume they're 75, and they have to be labeled.
Right.
And so I rewrote the exam question and said, terminations are labeled.
Yeah, exactly. All right, we okay here, guys?
Yep.
Let's move on. I'm going to 110.14d, torquing. At one time, there was no discussion of torquing in the code.
That's
And
correct.
then people were saying, you know, the product, UL White Book and products specifically have torquing requirements marked on them. Their instructions have it in there, and guys are not following the instructions or the markings. So they added torquing information as an informational note in the code book saying, hey, listen, you know, if there's marking on the equipment, whatever it is, then you need to comply with the markings in accordance with 110.3b that says you have to install things according to listing and labeling instructions. So that was informational note telling you to comply with the basic requirements of 110.3b. But that wasn't good enough because people say, hey, it's informational note. That's not a requirement of the code. So they took the informational note and they converted it into a requirement in 110.14d now in the 17 code. And let's read what it says. Where tightening torque values are indicated on the equipment or installation instructions, a calibrated torque tool must be used to achieve the indicated torque value unless the equipment manufacturer provides an alternative method of achieving the required torque. So let's take this one step at a time. Number one, we have to tighten it and we have to torque it. And we have to use a calibrated torquing tool. Brian, you want to tell us about a calibrated torquing tool?
Sure. Well, this requirement actually was recommended in NFPA 70B for quite some time, which is recommended practices for electrical equipment maintenance. And what a calibrated torque tool is a screwdriver, ratchet, whatever it might be, T-handle, and you purchase it from, for instance, let's just say Klein, and it comes to you with a serial number on it, and it comes with a calibration certificate that's typically good 1 year from the date of purchase. At the end of that year, that is no longer considered a calibrated tool because the calibration's expired, and you have to either send it off to the tune of about $60 probably to get it recertified, buy a $3,000 tool calibration tool, which has to be sent off and recertified.
That's A, that's B.
Yeah, that's B. Or C, you just buy a new screwdriver. So you know, however you want to look at it. But yeah, this is definitely.
But how will an inspector know if the tool you have is calibrated?
He would ask you to physically produce the calibration certificate, and he would have to compare the stamp serial number on the tool with the serial number on the actual certificate.
Now, can you tell us about 70B? some of the, and we probably should get a slide on there next time,
Sure.
about what are some of the things it tells you in 70B about
You know,
the torque?
70B actually, and this is kind of a new revelation for me. I wish I would have known about this years ago, because we've had this conflict about inspectors wanting to check torque on things, or maybe a client wants us to check the torque on terminals. And I had always heard and read little snippets of things saying, yeah, you don't want to do that. And the reason you don't want to do that is you keep tightening things. The wire actually, it does what's called cold flux, and then it has creep, and the wire just gets thinner and thinner and thinner, and you're changing the property of the termination, and it actually will not carry as much heat away from the connection. It overheats, and you have a failure. And so what you actually would have to do then is actually cut the end off if it becomes damaged and re-terminate it. Well, 70B actually details this and says, hey, you got some options. Number one, you can use thermal imaging. Number two, you can do a low resistance ground test and compare it against other connections for similar readings. Or you can do it the easy way. And that is, instead of retorquing at 100%, you do it at 90%. And as long as it doesn't move, you're good. If it moves, guess what you have to do? Start over at square one.
And then you torque them.
And you torque them. And so that's actually what ended up, I think, being the go-to solution is, hey, if it's asking for 100 inch-pounds, go to 90, test the connection. If it doesn't move, you're gold. If it does, you know, you need to redo it.
Okay. All right, now let's take a look right here. Here's the torque in inch-pounds. So there's the wire size. Here's the torque. There's wire size, 25 inch-pounds, 6 larger wire, larger inch-pounds. And this label, this tells you right here that you can, by the way, have 2 14 or 12 gauge conductors under a single terminal. So sometimes, well, how do you know how many wires can have? Well, right there, 2 12s or 10 aluminums. And of course, here is the inch-pound torquing in there. Yeah, for the equipment grounding conductor, exactly. Now, it says you do the torquing, calibrate it, or unless the manufacturer provides an alternative method of achieving the required torque. And anybody familiar with that one, Michael?
Well, I'd just like to say, this is something I see problems with across the country. Because I travel the country, nobody likes to torque their conductors. So unless they're forced to do it, they don't pull out a torque wrench. They tighten them in the old school way, they hear it creak and stop. So you're having to force this application on them.
Well, 70B also says this, Brian, I think you remember this, that once you torque it, you should mark it.
Yeah, that's true. It does say that.
So you put like a little,
the practice is a black Sharpie, and you
like
just
a
put a
black
line
Sharpie,
all
just
the
to
way
kind of
across
identify
it. Yeah.
that we've torqued those things. And if the inspector gets it, I'm not quite sure whether you torqued it. You tell, yeah, I torqued it. Let me get my little torque wrench. Let me see you calibrate it. So, okay. And then, like you said, if you go to 90% and it doesn't move, then it's fine. If you go to 90% and it's moving, do the whole thing all over again.
The only thing the 90% doesn't tell you is if the guy torqued it to start with, because if he over torqued it, it won't move at 90% and it's still wrong.
Right. But
So-
the thing is this.
Right.
Over torquing is done about, I think, about a third of the time.
Right.
The studies have shown.
Yes.
A third of over torque, a third under torque, and just a random event.
Right.
A third is right. Somewhere, maybe the numbers are not right. There's people that have done studies on that. Okay. The other method of achieving torque is, you guys might have seen equipment that when you turn it, it has like a head, 2 heads on there, and the heads just break off because it got to its right point and just they're designed
To shear.
to shear. Thank you. That's the right word to use it. To shear off.
Yeah, also in the bottom of the slide it says, unless the manufacturer provides an alternative method of achieving required torque. So I have seen some on aluminum connectors where it says, bring the set screw down to where it makes in contact with the wire and then tighten another half turn.
Oh.
Okay.
Oh. Okay.
And that's
so
a
there's some other-
legitimate manufacturer's instruction.
Okay, so there's other ways besides just torquing, but we have to combine. So now it's a requirement. And I got a streamer saying, I have to buy a torquing screwdriver? Yeah, shit, I've always had a torquing screwdriver.
No kidding.
Well,
Great answer.
Let me give you my passion about this, okay? There's nothing I care more about than to save lives. 90.1, the purpose of the NEC is the practically safeguarding persons and property arising from the use of electricity. And what was it? We talked about it was fires and it was electric shock or electrocution. Fires come from what? Comes from terminals. Where are you going to have a problem? What's a sense of doing all this mechanical work? What percentage of an entire job does it take to torque it? Well, Mike, you're going to torque receptacles? Okay, here's probably what I would do if I was honestly an electrical contractor. I would take a torquing screwdriver, and I'd have a guy go around, and listen, do me a favor, go around and torque these receptacles, just so you can find out what is the setting that you would feel. Because some guys, big guys, you know, Michael, you might be bigger than me. I mean, you might be breaking that set screw that you set in there. Where me, I might not having enough, okay? And Brian, you might have been just right.
We actually had and I know it's probably not an approved method by any stretch of the imagination, but my guys like to use screw guns, which everybody cringes at. And what we would do is we'd actually take the torque screwdriver, our Klein torque screwdriver, we'd tighten a terminal, and then we'd start on 1, 2, 3 until we found the one that just barely made it move, and that's what the guys used to tighten all the terminals with. 4 devices. Everything else we used a calibrated torque tool for.
I like that.